Okay, so what we have is, in problem 5, is the revenue function, which is linear. It's 1,000,000 plus 50,000 T. Graph of slope 50,000, y-intercept 1,000,000. Okay? And we're going to look at this over a period of 8 years to start with, but we're going to actually go beyond that. So I chose the scale. In 8 years, this is going to be up to 1,400,000, right? So 8 times 50,000 is 400,000. Okay, so that'd be 1.4 million. So that makes sense. 1.4 times this, yeah. Okay, so there's the graph. Okay, and then we have cost. And the cost, somewhat unrealistically, starts out at 0. I could have added a constant on this 100,000 or something like that, but I didn't. It's 100 T squared plus 20,000 T. So the cost now that's a parabola. Vertex at T equals negative 20,000 over 2 times 100, basic property of a quadratic function. If this is A, this is B, and you could have a C over here, it's like AT squared plus BT plus C. We know the vertex is at negative B divided by quantity 2A. Just a basic property of parabolas that we want to keep in mind. So there's your vertex, and that's equal to what? That's 20,000 over 200, so that's negative 100. Negative 100. Yeah, it is. And the value of the function at negative 100 is way low. So in any case, you then have a parabola that's got an upward slope at this point, and if T is big enough, it's going to intersect, well, being a parabola, it's going to intersect the linear graph. An upward opening parabola has to intersect any linear graph that starts out above it. Okay? So, we're not interested necessarily in the intersection point yet, but some of the later questions we will want to find it, and it's easy to do with the quadratic formula. So I said, well, let's first approximate this function by each with 4 trapezoids, from T equals 0 to T equals 8. And then interpret the area of each trapezoid. Now, I'm not going to actually do the trapezoids. Let's just take a typical trapezoid and interpret it, because the arithmetic of setting up and finding the area is very trivial. Okay, so let's just say that this is a trapezoid here. For the upper function. And we have another trapezoid for the lower function. How's this relevant to what we're doing? Well, if you find the area between these graphs, what's that mean? Well, let's look at one trapezoid, okay? Now, an average altitude of this trapezoid represents I'll just use REPR for represents an average cost in that interval, right? Okay? And its average revenue. And on this interval, What's this represent?
That would be the average cost.
So, what's the average profit on the interval?
That would be subtracting the cost.
Yeah.
That makes sense.
Um, I wrote that. Approximate cost, profit on an interval. And I said some wrong words in the interpretation. This is your revenue function. It's not the average revenue. It's the average revenue rate. The average rate at which you're accumulating revenue. Okay? And this is the average cost rate. That was careless. Okay? Okay, so I'm going to put the word rate on here, the average profit rate. What's the width? Represent.
Over, like how much time?
Yeah. That's your time interval. Okay? Width represents the time interval. What do you get if you multiply? Well, the average altitude times width for your R function, your rate function, your revenue function, sorry, represents the average rate, and I'll write it out a little more. Average rate at which revenue accumulates times the time interval. Which is the approximate revenue during that interval. Okay? Now, average altitude times width for the cost function represents ... The approximate cost during the interval. Okay? So areas under the area under the revenue graph between any 2 points is going to end up representing the revenue during that interval. And the area under the cost curve will be the cost during the interval. So from 0 to 8, and if t equals 8, let's see, this is going to be 6,400, and this is going to be 160,000. That's going to be about over 200,000, 224,000, I think. And when t equals 8, this is 1.4 million. So this is way more than the cost rate, okay? So, 8 is probably going to occur somewhere, maybe just around here. So you're just looking at the area of a chunk of this region between here and here, right? So you can easily do the interval. And you integrate revenue function minus cost function. Based on this interpretation, you understand that would give you the profit. Does that make sense? Well, we're not just out of time, but well over time, so I hope I haven't held you up.